in Chem2A format and H plus in front of the molecule. So like H2SO4, HCl, things like that would be acid. Alright, so that's all I got to say about acids, bases. Let's go over to redox. And let's try a redox reaction to kind of get rolling here. And I have one over here for us to give a shot on. See how it goes. And there's a number of different, you follow the same method for redox reactions. Of course, you can have like nearly infinite numbers. If you need more practice, check out the practice exams. Check out the back page of your homework. Not the back page, but the end of your chapter where it has all the homework. There's plenty of examples there. Let's try one right now. We'll do this one. O2 plus, and let's see, NO goes to H2O2 plus NO3 minus. Alright, let's try to balance this craziness. Okay, so you want to split out first likes with likes. So you see there's nitrogen, so you go NO goes to NO3 minus, and then you can go O2 goes to H2O2. So I'm putting the oxygens together that are not with the nitrogens, and then the nitrogens together. Okay, now we can double check the charges on these, see what they are. This oxygen is 0, and this oxygen over here is -1. When it's with a peroxide, that's one of the examples where you see a -1 with the oxygen. Actually, the only one that will give you that has a -1 for oxygen, because each hydrogen is +1. Okay, in this other example, this nitrogen looks like it's +2, and this one looks like it's, I believe, +5. So you can see that the top one increases in oxidation state. So I'll just put the label over here. This is the oxidation half reaction, or nitrogen gets oxidized, or you could say NO gets oxidized. And then the O2 goes down from 0 to -1, so we'll call that the reduction half reaction. Or you could also say that the oxygen was reduced, or you could say that the O2 was reduced. Either way is totally fine with me. Alright, now let's go through our 4 steps to balance this. Okay, step 1, and we'll do the top reaction first. You balance the nitrogens, anything that's not oxygen or hydrogen. Those balance, 1 on each side. Step 2, you balance the oxygens. There's 3 on the right, 1 on the left. So I'm going to add 2 H2O to the left-hand side. Now there's 3 oxygens on each side. As you can see, that messed up the hydrogens, so thus we have step 3, we balance the hydrogens. And so there's 4 on that side, so I'm going to put 4H plus on this side. Step 4 is you balance the charge, and you can see the H plus kind of monkeyed with the charge a little bit. So on the left-hand side, there's 0 charge right now. On the right-hand side, there's -1 plus 4. Common mistake, students don't multiply 4 times +1 for the coefficient, so you gotta remember that. So it's +3 on the other side, +3 here. So to get the same on each side, I'm going to add 3 electrons. In this case, it happens to be 0 on both sides. Doesn't have to be that way. Alright, now let's do the bottom case. First, there's nothing, don't do the first step, there's nothing that's not oxygen or hydrogen. Okay, step 2, we got 2 oxygens on each side. That looks pretty balanced to me. Step 3, I need to add hydrogens to balance both sides. So 2H plus on the left will balance the 2 hydrogens on the right. And then, so I need 2 electrons plus 2 electrons. And it looks like that's all balanced out now. Fantastic. Let's get a different color pen. We're going to add this up. We need to make sure the electrons all cancel out. Okay. So, since there's 2 electrons on the bottom and 3 on top, I'm going to multiply the top by 2 and the bottom by 3. That'll give 6 electrons on each side, and they must cancel because electron is the intermediate. So that'll get us, I'll do all the reactants first. There's 4 H2O plus 2NO plus 6, oh my goodness, 6H plus 3O2. Okay, that should be all the reactants. Now I'm going to move over to all the products if I haven't made a math mistake. Let's see. On the products, we've got 2 nitrate ions plus 8 H plus 3 H2O2. Fantastic. Alright, now let's see if anything cancels from both sides. H plus does. Check that out. There's 6 here, and there's 8 here, so that leaves 2 H plus on the right hand side. That would be the acidic answer once I cleaned it up and wrote all the state symbols in, which would be liquid. I believe this is a gas. This is a gas. This is aqueous, and this could have come in a couple different forms. It depends how it was written in the problem, but most likely a liquid. Let's see how it's written in the problem. It came as aqueous, so we'd write it as aqueous. Now I want to do one more step. Let's pretend they asked us for a basic solution. If you wanted to do this in basic solution, you find the H pluses, and there's 2 here on the right, and you add 2 hydroxides to each side. Remember to add them to each side. Okay, so you add 2 to each side because there's 2 H pluses. Add that up, you get 4 H2O plus 2 NO plus 3 O2 plus 2 OH minus goes to 2 nitrates plus 3 H2O2 plus, now I have 2 H pluses and 2 OHs, so that's going to be 2 waters. Okay, now notice the waters will simplify because there's 2 waters on the right. That'll cancel with the 4 on the left to make 2 on the left. And now if I just clean it up a little bit and write all my state symbols, I'll be good to go. So there's 2 H2O, which was a liquid, plus 2 NO, gas, plus 3 O2, gas, plus 2 OH minus, aqueous, goes to 2 NO3 minus. Remember, everything with a charge that's not 0 is going to be aqueous. And then in the problem you would have been given that H2O2 is aqueous. And that should be everything. There's your final answer there at the bottom. In basic form, and you know it's in basic form because you have the hydroxide. Alright, so make sure you do a number of these. They always follow the same format, and you don't want to get messed up by them. Kind of variation on this, just as an easy question, they could ask you what's the reducing agent. You would have said whatever got oxidized, which was the nitrogen or the NO. So that is the reducing agent. Thus the oxidizing agent would have been oxygen or O2. Alright, so raise this. Next, let's see. Let's do a little bit of a really quick titration problem, because that might be on your mind. Let's say let me put up the reaction I had before. I believe I had this ammonium hydroxide plus HCl goes to ammonium chloride plus H2O. And then, you know, it's a titration problem. Usually it'll say the word titration or standardization or neutralization. It might say that. And they'll give you usually molarity and volume units, but they don't have to. Though usually it'll be something involved with molarity. So let's say I had 2.0 molar of ammonium hydroxide and there was 20 milliliters of it. And then let's say I have 30 milliliters of the HCl and I want to know its final molarity. Okay, this would be a pretty typical problem. So what you do, you start with what you know.